Hello and welcome to ACM's first ever Learning Center webinar, the first in what we hope will become a series. This webinar reflects ACM's deep commitment to lifelong learning. Our aim is to empower computing professionals and students who join ACM's worldwide community of 100,000 plus members. My name is Dave Johnson. I'm the past chair of ACM SIGMOBILE and am a professor of computer science and electrical and computer engineering at Rice University. I'll be serving as the moderator for today's webinar. ACM offers innovative educational and professional development resources that bolster skill sets and enhance career development opportunities. Our members are able to stay competitive in the dynamic computing world with a range of ACM Learning Center online resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. Together with timely computing information published by ACM, access to the ACM Digital Library, the world's most comprehensive database of computing literature, and international conferences that draw leading experts on a broad spectrum of computing topics, ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Today's presentation is The Cloud in Your Hands, Marriage of Cloud Computing with Smart Devices by Arjmand Samuel and Danny Dalal of Microsoft Research. Before we get started today, I'd like to mention a few housekeeping items. At the end of our presentation, we will have time for questions, and we hope you have several. Also, watch for live poll questions such as this one during the presentation. You can submit your answer now by clicking on the Submit button. In the top right corner of the slide area on your screen, there is a green button that will allow you to enlarge the slides. You may also enlarge the slides at any time by dragging the corner of the slide window. The slides will advance automatically throughout the event. You can minimize the slide area, Q&A, and bio windows using the buttons on the bottom panel. If you are experiencing problems with the program, please press the F5 key on your keyboard to refresh your console, or close and relaunch the presentation. You can also visit the webcast help guide by clicking on the help widget below the slide window. Please disable pop-up blocking software so that you can receive and respond to the feedback form at the end of this presentation. To control the volume, adjust the master volume on your computer. This session is being recorded and will be archived. It will be available for review within about 48 hours at learning.acm.org/webinar/pilot. If you think of a question during the presentation, please type it in the Q&A box at the lower left on the presentation screen and click on the Submit button. You do not need to wait until the end of the presentation to begin submitting questions. And now I'd like to introduce our speakers. We are honored to have presenting today Arjmand Samuel and Danny Dalal, both of Microsoft Research. Arjmand Samuel is a Senior Research Program Manager at Microsoft Research Connections, where he is responsible for building academic research partnerships related to mobile computing and software engineering. His recent research interests are in the areas of cloud-enhanced mobile computing. He is spearheading the academic outreach component of Project Hawaii, a cloud-enabled mobile development platform for Windows Phone. Danny Dalal is a Senior Development Lead at Microsoft Research. He's worked on video on demand at Oracle and at Microsoft. Early at Microsoft Research, he contributed to what later became Windows Presentation Foundation and Silverlight. Danny has also contributed to Visual Studio, BizTalk, and Windows Fabric. He's currently managing a number of open source projects in computational biology, machine translation, Earth visualization, and cloud-enabled mobile computing. Arjmand and Danny, we look forward to your presentation here today.
Thank you very much, Dave, for the introductions. I am Arjmand Samuel from Microsoft Research, and as the title of the talk suggests today, we will be putting the cloud in your hands. Actually, that is what we'll be doing in the next 40 minutes or so. We'll be talking about a radically different yet simple way to develop mobile apps, and we'll be using the cloud-enabled mobile computing architecture. We'll introduce you to the Hawaii SDK, which has been developed by Microsoft Research. An academic version of Hawaii services has been used by the academic community for more than a year now. But in a few months, we are planning to make Hawaii services available to the larger developer community as well. Today, you'll have an opportunity to sign up so that you are informed when the Hawaii Tech Preview for developers is available. To introduce you to Hawaii services, we will walk you through a mobile app for Windows Phone 7, and Danny will be doing that in a little while. You can ask questions anytime during the webinar, and towards the end, we'll answer these. If you still have questions, you can send us an email at hiforum@microsoft.com. Let's just dive into this interesting world of cloud-enabled mobile apps. Now, have you ever thought of developing a simple OCR and translation app for a mobile platform? So here is a scenario. Let's say you're in China and you love a certain dumpling, and you cannot read the menu since it is in Mandarin. Also, no one in the restaurant speaks English. You could pull out your smartphone, take a picture of the menu, and which may be in Mandarin, and the app could OCR it and then translate it in the language of your choice. One could run the OCR and translation engine on the phone itself, but such algorithms tend to be resource hungry and require a lot of computation and storage. On the other hand, running these in the cloud, which has tons of processing and storage resources, much more than on the phone, makes more sense. In other words, smartphones with their sensors and mobility leverage the cloud for resources and connectivity. This indeed is a marriage made in heaven. Let's now get into some details of the current offering of Hawaii services which we have for the academic community. As part of Hawaii services, we offer an optical character recognition service and a speech-to-text service. You could use the OCR service to do optical character recognition of an image and extract the text for translation, as an example. Similarly, the speech-to-text service allows you to record speech and convert it to text in the cloud. And then you could use it for translation or for some other interesting scenarios on your phone. Another offered service is the relay service, which enables sending of text between mobile endpoints, which may not be discoverable otherwise. Similarly, the Rendezvous service provides a mechanism to map endpoints to human-readable names. These two services are very useful when dealing with mobile devices, as otherwise there is no consistent way of addressing them. Let's now see a demonstration of the relay and rendezvous service. This demonstration app has been developed by students and researchers at Singapore Management University, and it allows synchronization of video between two mobile devices. Let's see the video.
Hi, this is Rajesh Balan, Assistant Professor in School of Information Systems at the Singapore Management University. I'm presenting a demo application for Project Hawaii's Relay service. In this application, we have a video player that synchronizes between two different phones that are geographically dispersed. What we can see in this demo is the left phone is playing a video while the right phone is waiting because the left phone is actually playing parts of the video that the right phone has already seen. When the left phone catches up, you will see that both phones start synchronizing. At the same time, this allows people who are geographically dispersed to be able to see videos together in a shared interactive manner. They can also exchange text messages with each other, and they can also send audio chats to each other. We will now see that if you look at the display down here, you see that the left phone is 5 seconds behind the right one, and they have now caught up. And both phones are in sync. And everything is streaming through the relay service, even though the video is located somewhere on the internet. As I will show you now, you can even send voice messages to each other. This is a great video. And that concludes the demo of the relay service demo application. Thank you.
Danny will talk again about relay and rendezvous services when he walks us through an app which uses these services. I will now talk about two of the upcoming cloud services we are working on. The first one is the face recognition service. Imagine I take a picture of my research group with my phone, and I want each person tagged correctly in the picture. I can use the face recognition engine in the cloud to do this accurately and quickly. We are developing this as a generic face recognition engine as a service so that any image processing app can take advantage of it. Now, the second service we are working on right now is the service composition framework. What if your app requires multiple services? Let's revisit the menu translation app. Since it requires OCR service and the translation service, we would have to make multiple network calls. However, with the service composition framework, we could compose services in the cloud and make only one call from the phone. The service composition framework would also be available in the near future as a cloud service. Now, if there is a cloud service you would want to see and you would want us to develop and work on, here is your chance to give us some feedback. On your screen is a poll question. You could type in very briefly what you would like to see in terms of a service, and then it clicks Submit Answer. I'll wait for a few seconds here so that you can type that in. So as you would appreciate by now, the value of cloud-enabled mobile computing really kicks in when you have access to heavyweight algorithms doing some very interesting tasks in the cloud. Microsoft Research has been developing these algorithms for many years now, and we are planning to make these available to developers in the form of cloud services. Starting in spring this year, you can evaluate a tech preview version of Hawaii services for free. Subsequent to that, we will have a tiered subscription model. Needless to say, the Hawaii services for research and academic use is available right now, and you can start playing around with it today. Let me now hand over to Danny, who would be walking us through an interesting app using Hawaii services and SDK. He would show us that developing mobile apps using the cloud-enabled mobile app architecture is simple and quick. Danny, over to you.
Wonderful. Thank you, Arjmand. My name is Danny Dalal. I work with Arjmand as well in Microsoft Research, and we built the Hawaii SDK platform a few months ago along with another team here in research. I'm going to take you through a little contrived scenario that will sort of motivate why we'd want to use Relay and Rendezvous, which I'll explain to you in a couple of slides. Also, there's been a couple of good questions about whether or not this SDK is usable on other platforms. The good news is that these services are exposed through a REST layer, so you can just do HTTP over REST, and it's well documented. So you can write your own apps on other devices or other connected devices, including computers, to hit up these services. What we provide is an SDK that runs on Windows Phone 7 to make your life a lot easier. And it's asynchronous and does a lot of work in the background for you. So let's just get through this scenario real quick. I came up with a scavenger hunt or a geocaching type of scenario because, you know, real life is a hassle, digging is hard work, finding things is a lot of work as well. So let's just do all of this digitally. Connected cloud-enabled devices make these kinds of scenarios more flexible with less manual labor, and it also enables a whole other class of scenarios like leaving messages behind or leaving pictures behind, or hide and seek, or digital graffiti, or location-based advertising. And one of the things that I'd like the audience to think about while we're going through this deck and the code is how these services can apply to you and your world, and how you can leverage Relay and Rendezvous, for example, which I'll explain in a second, and some of the other services we mentioned. So let's go to the next slide so we can talk about what the scenario looks like. So on the left, we have a modern mobile connected device, which I really want to have. It'll probably weigh 10 pounds and have big push buttons on it. On the top right, we have Relay and Rendezvous in the cloud. And what I have here is a mailbox, or what I call a named queue. And that's where the people that are playing this game together will store messages or clues or items, depending on what you want to call it. For example, if we're doing geocaching, you can leave things around like apples or clues for wherever they're supposed to go next. If it's digital graffiti, you're leaving JPEGs, and it's up to you and your imagination. But in the cloud, Relay and Rendezvous will host these named queues. On the left, the connected mobile device participates in a group of people that are playing the game together, and it goes to the named queue and grabs whatever items are left behind it through a subscription model and a publishing model when you want to put something inside of this mailbox, if you will. We want to talk about what we're going to build, and here I'll describe Relay and Rendezvous to you. Relay and Rendezvous are two services that we're going to use, and basically, Relay is simple queues with a publish subscribe model. So you create a queue, you have subscribers on that queue, and you have publishers on that queue. And when you publish something to the queue or to this what we call endpoint, all your subscribers get a copy of that message. It's a pull model, so you have to show up to the mailbox or to the queue and grab the messages that have been sent for you or for your friends. And Rendezvous is something that's going to support Relay in that we have to know the name of whatever it is that we're going to look up, for example, the group name or the queue name, and Rendezvous is basically just a lookup. It's like DNS, but it returns queue IDs or mailbox names so that you know what you're going to go pull from. All right, so we're going to go ahead and use these two. Next, I want to show just kind of a high-level cake diagram for what we're going to build, or what we've already built, that I'll walk you through. So basically, the top two layers are what an application builder will have to write. The UX, which is going to be our code, and that's pretty straightforward. You got buttons and dialog boxes. And then the middle layer here is the digital, what I call the digital geocache services layer, or the scavenger hunt layer. And this is what provides services to the UX in terms of the Hawaii SDK. The Hawaii SDK are the bottom two layers in this logical stack. The Hawaii SDK is what Microsoft publishes, and it contains the wrappers for Relay and Rendezvous. And you'll note that the top three layers are physically on the client. That means that they're running on your phone, on your CPU. And then they're connected to Relay and Rendezvous in the cloud over your Wi-Fi connection or your 3G connection, and over HTTP REST calls. Okay, so let's go through the high-level architecture in terms of the calls I'll be making, and just so we can anticipate the methods that you'll see coming up. And then after this, I have a few questions for you guys. So what we have is basically three calls. It's really simple. We want to basically look up based on our current position and our group that we're participating in. So let's say you and your friends are called, the ACM group, and you're underneath a certain tree your friend told you about. You want to go look it up and get back an endpoint and see if there's a mailbox there for you. Once you have that mailbox, you want to go and grab an item and get the item from the mailbox, and they'll give you an item. And you want to leave something behind, possibly, so you can do a put item. And our simple UX just allows you to sign in with a group name, check your location, read and leave items or clues behind. So let's do a quick poll. I'd like to hear from the audience how much experience you have in this area. And I'm going to go ahead and push this poll to you. I want to know if you've built any cloud-enabled mobile applications before. And while people are doing that, let me see if there's some interesting questions that we can talk about. Are the Hawaii services accessible via Java? Probably. You can definitely write them over REST and HTTP because Java supports that, just like any other REST or HTTP platform. So it's totally agnostic. These services can be accessed over REST and HTTP on any platform. So let's see how the poll is doing. Yes, but the SDK is only available for Windows Phone 7, as I mentioned earlier. So it looks like most of you have not built any cloud-enabled mobile applications before. So this is going to be really interesting for you in terms of how easy it's going to be to build these kinds of applications. Secondly, it'll be interesting because most of this work that would otherwise be done on the phone, it can now be done in the cloud. So you'll be offloading a lot of processing and a lot of hard thinking to the cloud. So this is something you should definitely think about in your next, whatever applications you're going to do for your business or your industry. I'm going to go ahead and push these results out to the audience so you guys can see what the ratio is here. So it's about 90% of you haven't built these things before. So this is a very relevant, definitely a relevant thing for us to be talking about. So now let's go ahead and get to the code. I hope you guys like this cool graphic. I found it in clip art. So I'm going to just give me a second here to start my screen share so I can show you guys all the code and go through the methods with you. So you should see either a pop-up or something show up on your screen, and you should be able to see 3 methods in a second. So here we have the 3 methods that that we're going to write in what I call the digital geocache service layer. These 3 methods are create a subscription. As a reminder, this is the thing that says, hey, I want to subscribe to the things that are inside this mailbox. So whenever there's something in the mailbox, I should be able to walk up to it with my endpoint ID and say, hey, give me the message, and grab the message. And then we should be able to, given the subscription ID, we should be able to put an item into that mailbox, and we should be able to grab an item from the mailbox. Let's go ahead and write the code for create subscription, which uses the relay service. Okay? I see. So apparently nobody's been able to see the code yet because I'm not. The sharing is just broken down. So if you can imagine a bunch of code in front of you where we call the relay service. Let me give it a second for it to load up, and we can walk through the code. And the cool thing is all this code is baked. It's like a cooking show. So I'm going to write a couple of methods for you, and then we're going to go and play with the applications and see what we've stored around the world and what we can find. Right. So seems like we're having trouble showing this, trouble with the screen share. I'll continue talking about what Relay and Rendezvous provide, and hopefully when it comes up, I'll just go straight to the demo because we might run out of time. In the meantime, I will be multitasking to see if I can get this thing launched again. So as you know, Relay and Rendezvous provide this peer-to-peer messaging service, and Arjmand mentioned a couple other services like optical character recognition or speech-to-text, which both would be super-duper heavyweight on your phone and would consume a lot of battery and a lot of power and a lot of computational resources. So what's great about these services is that you can go to the cloud and you can say, hey, do this optical character recognition and come back to me with the results. And one thing that you could do with this application, in fact, when we're done, we don't have time to do it today, but one thing we could do is, for example, instead of typing a message to leave behind or grabbing one of the pre-baked messages, is basically go and say, look, I'm just going to speak my message and let it save it as a voicemail, or let it save it as the actual text. So, there's a lot of flexibility there, and you can imagine how powerful this can be once you compose these services for you in the web, or sorry, in the cloud, when they're all composed, so that you don't have to do all these round trips back to your connected device. So, Dave, why don't you go ahead and grab some of these questions while I get this thing going?
Sure. I'll start with. A lot of people are asking, will there be other SDKs? Arjmand, can you help with that?
Thank you, Dave. Yes, we are looking at a number of services. Now, the SDK is the software development kit, which is used to consume these services on a client, which is, in this case, a mobile platform. So we will, of course, release a number of SDKs which connect to different services. Now, these SDKs could be bundled up into one big SDK, or could be released separately. That is something we're looking at right now. But as of now, we do have a version which bundles up these 4 services, which is the OCR, speech-to-text, Relay, and Rendezvous together, and installs on your machine so that you can start developing these apps. And of course, the services are in the cloud. I hope that answers your question.
Thank you.
Dave? Yeah.
So another common area of questions, I'll paraphrase here. What is the tier subscription model, and will there be any subset of the services that are free?
Yeah, that's a great question. First off, tiered subscription is a term that is used to describe different paying models for different levels of service that you get. So think of it as if you have the first 1,000 or 1,000,000, whatever that number may be, hits to a service, that might be free. The minute you go from that 1 million to 10 million, that could be charged at a certain rate. And the minute you go from beyond that hypothetical number of 10 million to whatever, it might be charged at a different rate. So essentially, you set up a tiered subscription model where users who are playing around with it, or who are trying to see if it's a good service for them, can actually try these services out for free. But the minute these services get a take-up, which we hope, of course, you write apps and they are successful and millions of them are used all over the world, that is when the next tier of subscription would kick in. So that, I hope, explains a little bit about what that tier subscription model is. Dave?
Thank you. Another question, what's the relationship between cloud computing technology and things like VPN and grid computing?
Right. That's, again, a great question. So cloud computing is, I don't know if I have the time to really go into the really details of what cloud computing is, but generally speaking, anything which executes in a data center or is stored in a data center and is the user or the client does not need to worry about where it is stored, how it is stored, who takes care of the scaling up of it, is a cloud model. So as an example, these services, so optical character recognition being one of those, if you were to worry about the libraries that are required for optical character recognition, the algorithms that are used, and they need to be constantly updated. So you could actually put that in a machine on your own. But what if you could actually farm that work, all that hard work of making sure these algorithms are up to date, making sure that it works, off to somebody in the cloud, somebody whom you really do not care what and how it is done, and you essentially reap the benefits of all of that. Now, as another example, speech-to-text is a very typical example. you could host a speech-to-text service on your own client even, but that would have limited vocabulary. So many words that you say would be foreign to that library, and then you would be results from that cloud service would not be very accurate. On the other hand, if you could host this speech-to-text service in the cloud, now you have the option to host a large vocabulary, maybe multiple languages of speech that could be available out there. And you, again, do not have to worry who updates it and who makes changes to it. So that essentially is a cloud computing paradigm. Of course, we can talk more about that, but Danny is just telling me that his engineering finally worked, and we have the code available to you. I hope you can see that ACM demo namespace up there. Danny, over to you, and you can talk about the code.
Okay, thanks so much, Arjmand. All right, we got this fixed. Thank you, everyone, for your patience. Thanks, everybody, for covering and taking questions. All right, so what we're going to do is we want to basically create an endpoint async. So we're going to go grab Relay Services. Make sure I'm focused here. Relay Service. And grab the create endpoint async method. Now look, we see here that there's basically takes 3 arguments. The application ID and the name of the application, which are basically whitelist authentication that we're using with the service to keep you guys from having to sign up and register and all this stuff. We're trying to keep it super duper lightweight. Thankfully, we have one of these available. It's called the Hawaii Client, Hawaii Application ID. Awesome. And we'll just give it the app name. And then this is something I really, really like about C#, and that is that you can create these anonymous inline methods. So what it's asking for is an onComplete method. So this is an asynchronous method. What this really means is, hey, go create this endpoint and return to me right away. When you're done creating the endpoint, I want you to call me on this method, and this method takes 1 argument, and it's the endpoint result argument. And that packs up everything that we need to know after it's created the endpoint for us in the cloud. So this keeps the phone super responsive, and I highly recommend that you guys, when you build this stuff or when your developers build this stuff, that you're always getting them to use asynchronous code, because the way of synchronous is it's ancient and nothing should block anymore. So let's just create an anonymous method here. I'm going to create an argument called endpoint. And this is shorthand notation for, hey, I'm creating an anonymous method. It knows what the signature is. It knows that it's going to take an endpoint type. So first we're going to just assert that the endpoint isn't null. Right. Just to make sure that there's no bugs in our program. Then we're going to check the status of the endpoint. And then, I'm only going to do one of these because I've been to a lot of webinars as well. And at some point, you go, okay, let's see the results. So let's go grab endpoint.status. I always joke around with my developers and basically say, coding has become so easy that all you have to do is just tab, 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 and there it is. All you need to do is tab, and you have basically the entire code just appears in front of you. It's so straightforward. So let's see if on success is, oh yeah, sorry. So what I didn't mention up here, so let's go to the top a little bit. Remember when we first started, when I thought that everybody could see everything, we have 3 parameters to this method. One of them is called onSuccess, and the other one's called onFailure. What this basically says is, hey, when you're done creating the subscription, if it succeeds, call this method. Now, we wrote this code secretly earlier, and I'll show you this code. As soon as I'm done with this method, I'm going to go show you that code. And what that basically does is it separates the 2 layers. You have the UI, which knows what's supposed to happen after you give me the subscription. And then you have this layer, which knows what's supposed to happen in order to make the subscription work. So we just want to make sure that this method that's passed in is actually legit. So if it's not null, we're just going to call it. And we're going to call it with the endpoint that comes in from our result. And there's an endpoint object there. I'm going to hover over this so you see what the type is. This is an endpoint, and it basically represents the subscription that we're trying to get. We'll just close these guys. And otherwise, if it's not error, basically, big error, someone created a bug, right? So we'll just ignore that for now for time. And let's see. Okay, so basically, I think we're pretty much done. Give me a second here to check out the rest of the code. Right. Okay. So basically, we're pretty much done. I'm just going to close this method, and that should be basically it for this method. So now I'm going to go to the other file. I'm going to save this guy. Let's compile it in a bit, and I'm going to go to the other file and show you who calls the create subscription method. So now we're in another call, and this is the create endpoint. And right here, where is the create subscription? Okay, so this is the create subscription method, right? Now this is what you don't see is this file is called mainpage.xaml.cs. This file basically interacts with the UI. And what you'll see over here is that we've set up the onSuccess callback, basically, or continuation. And if it succeeds, we invoke back to the UI and we say, hey, we're going to set some state inside of our application, and then we're going basically to grab the container and set up the location on it so you can see it in the UI. And then if it fails, we're going to pop up a message box to the user to show them that it failed. So hopefully, I know this has been kind of fast and it's confusing because you haven't seen everything yet, but if you can imagine, the UX calls this when a button is pressed, calls this method, create endpoint, okay, and then it does a bunch of hygiene stuff over here. After that button is pressed, it does the UI-related hygiene, then it sets up these two callbacks right here, and then calls the method we just created below with the onSuccess and the onFailure. So, and in the meantime, since this is asynchronous, it just goes back and it waits. So the UI is still live. So what I'm going to do in the interest of time is I'm going to go ahead and run this code. I'm going to comment out the other code that I had below. Save this. I'm going to compile it. Okay. Just give me a second here to get this code up and going. What I've done is in order to make sure that everything runs, I'm going to use the original code because I don't want to waste everybody's time in code, brand new code. Okay, the build succeeded. You'll notice here I put a region called real code, just so I know. Okay, awesome. So let's go ahead and start this in the emulator. And this is going to be pretty cool because the emulator is really powerful. Now, you should be able to see this on your screen in just a second. This is the Windows Phone 7 emulator. And here's our little application. Now, you haven't seen a lot of this stuff. We're going to have to skip how we got there. But this is very simple. My name is Danny, and we have that in there. And then the group name is ACM Group. We're going to go ahead and join the group. Right? What this does is basically says we're part of this group. It goes and looks it up in Rendezvous so we can go and grab endpoints later. Now, what you'll notice on this screen is we have my items. These are the things I can leave behind. And then we have latitude and longitude. I'm going to show you another cool thing about the emulator. It can emulate a map and longitude and latitude. So basically, let's go leave something somewhere. How about where we work, which is somewhere in Microsoft. So let's just go over here and pick a spot, one of the Microsoft buildings, and that's it right there. So you'll notice that the latitude and longitude changed, and we're going to leave some stuff there. Let's leave an apple and an orange, all right? And then let's pretend that somebody else is playing this game, and they come over here, and then they leave something in this park, all right? So this is a completely different lat long. It's a 4764 and 12214. So let's go and leave cranberry juice and pepperoni pizza over there. Okay? Let's just change our position. We're walking around campus. And we'll come back over here and we'll see Now you have to be pretty close. You can set up your resolution so that you're close enough. But let's see what we can find over here. Find items. We'll call a method that will go and look for items, if you remember earlier. Okay, it turns out that we have apple, orange, cranberry juice, and pepperoni pizza because we're probably too close. So I'm going to leave some items somewhere very far away. I'm going to leave some water. And I'm going to change my location and then come back over here and see what I find. Nothing. Let me get closer. And this is basically running against the web, against these services. All right, I don't know why I can't find anything here. Oh, there's the water. So I was just too far away. Now, as my peers over here will know, and as you guys know, this application is called Hawaii. The SDK is called Hawaii. I'm going to go here to Hawaii. And I was recently actually visiting Hawaii. I was in Kauai. And I found something very interesting over there. Let's see if we can find it again. I was at the Princeville. Let's set our location over here and clear this item. Let's see what's over here. Something maybe interesting. Oh, look at that. We found Jimmy Hoffa, and he's hiding in Princeville. So hopefully you guys get a sense of the power of this, and it's building blocks. And you can basically find Jimmy Hoffa using the power of the web and the power of the cloud. No, just kidding. So I would just want to kind of remind you of what we've done. We've basically used Relay and Rendezvous, which is anonymous pub/sub, publication subscription. We've created mailboxes around the world that participate in a group. We've left things inside of those mailboxes. People can pull them out and put other things back in, and other people can come by and find them. Now, you let your imagination go wild. Imagine if we had OCR, for example, running, optical character recognition, which can be easy to add here, and you take a picture of something, and then the characters will be saved in that area. And then once all of these are composed in the cloud, the turnaround bandwidth, the turnaround will be much shorter, and you'll use a lot less of your phone's bandwidth in doing cloud-based operations. So that concludes this part. I think we're going to go ahead and go back to the slides and start taking some questions. And I want to thank everyone for their patience and for attending, and hopefully this was super duper useful. I'm going to pass it over to Arjmand. Again, my name is Danny Dalal from Microsoft Research, and we're going to take a bunch of questions. So thank you very much.
Thanks a lot, Danny, for the cool demonstration. I hope you all had as much fun as Danny did developing this cool new game. I think we should play this game later today, maybe. We just saw how simple and easy it is to develop cloud-enabled mobile apps using the Hawaii SDK. Now, if you have questions, you can ask right now. Also, if you'd like to send in a follow-up question, please send your question to hawaiiforum@microsoft.com. That's the email address that we have. I will now hand over to Dave so that we can take in questions. Dave?
Thank you, Arjmand and Danny. That was a very interesting presentation. So we have a number of questions. I'll start with the first question. A number of people are curious. Can you explain the name Hawaii?
Well, Hawaii, of course, has almost nothing to do with cloud-enabled, though one could argue, Hawaii, it's always sunny, you hardly get clouds, but when you get them, they're beautiful. So maybe that's the reason. But the real reason is our research team a few years back, 2.5 years back, was in Hawaii, and we were thinking about some interesting things to do. We came up with this idea, and the project was referred to what we talked of in Hawaii. And so what we talked of in Hawaii then got shortened, and it now became Hawaii, and hence Project Hawaii.
Makes sense.
Yeah.
Okay, so another question people are wondering about, can computer science students evaluate and use this system for free? And if so, are they required to go through their universities?
Again, that's a very interesting question, and I'm pleased to tell you that we have been working with a number of universities for the last 1.5 years now, and universities and students and researchers, mostly in the academic community, they have been using Hawaii for this time in their coursework. So students who would be taking classes in cloud computing or mobile computing and would like to have hands-on experience on using services as a component to their applications on the mobile use Hawaii. So the free Hawaii SDK is available for the academic community, researchers, students. You simply have to go to research.microsoft.com/Hawaii. That's the URL, or you could search on Bing and say MSR Hawaii, and you'll be taken to this Hawaii SDK. You can download that, play around with it, and of course that version is a free version. It's meant for academic and researchers at this time. Dave?
Okay. Here's another common question. What kinds of clouds can this be used with? Is it a single public cloud? Can you use it with private clouds? Has it been tried on the Amazon cloud?
Yeah, that's again a great question, and I could see that as a theme in a number of questions. So we right now host these services in Windows Azure, which is Microsoft's offering for a cloud system. We do not give out the source code or the executables for the services to be executed anywhere. Though you could always set up your own service, your own server, and then host a service on it, and then have a mobile device or a desktop machine talk to that service, and it would work. But these specific services are right now hosted in Windows Azure, which is Microsoft's cloud version. There was another comment earlier that do we plan to do a cross-cloud kind of an architecture? Right now we haven't investigated that. Right now it's just one monolithic cloud that we are working on. But of course, just a reminder, Windows Azure is not just one data center or one machine. It's a huge data center, a set of data centers which are spread across the world. And so these are multiple data centers, though it is abstracted from the user. Dave?
Okay, thank you. Is it possible to maintain a database on the cloud?
Yes, it is surely possible to maintain a database in the cloud, and Windows Azure gives that capability built in. The design there on Windows Azure is to have a huge database or a collection of data, and then you could put services, and then you could have clients access those data elements from the cloud.
Okay.
Dave?
So does the speech-to-text work only with English, or does it also work with other languages?
Right. So the version that we have right now for the academic community, which is the speech-to-text service, only works with English language at this time. Though as we move on, of course, adding languages is something that we are looking at, and we would like to do that. And as you would know, all products that are released by Microsoft are localized to hundreds of languages. So the same would apply to this once we are ready to release this as a full-fledged offering.
Okay. So what are the network bandwidth requirements to use the service? For example, large things like video and image processing.
So it really depends on how big those things are. But what we do when we wrote the OCR app is we compress the video. We compress the image to a level that our services had high accuracy with, and we made the bandwidth accuracy trade-offs. Same with speech to text. We basically sampled the sound at a certain rate and made sure it was mono and all of that. Then we compressed it a little bit and we sent it off. The response time is pretty fast, and those are relatively small when you consider how much data these phones push through. So the other trade-off that you're probably hinting at in answering this question is it worthwhile to send all this stuff up to the cloud versus processing it on your mobile device? And the answer is usually yes, especially when these are heavyweight processing things. So you get a lot more power in the cloud, whereas if you were to wait for your phone to do all the processing, you'd only get maybe a little bit of that done, and it may not be satisfying to the user. So we believe that the trade-off is usually worth it.
Thank you,
Dave. Back to you.
So another question maybe you can help us with, Danny. Does the relay service use a pull-only method for message delivery?
Right now, yes, it does. Yes.
Okay. Are there APIs or documentations available online that people can get more information with?
Yes, Dave, thank you for the question. The services which are released right now have a lot of documentation available online. So we have some guides to help with what are the key basic scenarios, how to consume these services, and also some of the inside architecture of how these services work. And these are on the Hawaii website.
Okay.
Dave?
Thank you. A common question seems to be, what can you say about security and privacy authentication issues such as that in the cloud?
Okay, so depending on, that's a pretty broad question. So for this, since it's a preview and basically pre-beta, we made security and authentication really lightweight. In terms of enterprise business use for Azure, Azure provides hardcore real security and authentication and encryption, and also provides guarantees to separate your data from other people's data. But yeah, as things move, as more and more things move to the cloud, security and privacy are definitely going to be issues that people are going to tackle. And so far, it seems like everybody is willing to make those trade-offs. But for businesses or industries where security is super duper important, they're best served by having a local cloud, which is something that Azure will probably offer in the near future. But as far as these little services are concerned, we basically have a whitelist-based authentication so that you can't go beat up on the servers. But we make no promises in terms of privacy and all of that, because these are just for preview and for play.
Okay, thanks. So another interesting question that maybe you can help us also with, Danny. What program are you using?
Okay, so I am using Visual Studio 2010 with the Windows Phone 7 SDK installed on top of it. The Windows Phone 7 SDK is free. It comes with a little version of Visual Studio, so you can start developing Windows Phone 7 apps right away. The emulator that you saw is part of that SDK. When you run your app, the emulator pops up if it's a phone project. So yeah, so it's Visual Studio plus the Windows Phone 7.1 SDK, and it's super duper easy to find it online. Just type in Windows Phone 7 SDK and you'll go get it.
Okay, thanks a lot. So I think we've pretty much run out of time for questions today. Thank you very much for the answers. So this webinar will be available on demand at learning.acm.org/webinar/pilot. And don't forget to check out ACM's other great learning resources in the area of mobile computing and beyond. In closing, I'd like to once again thank Arjmand Samuel and Danny Dalal for their informative presentations and their insightful answers to the many questions. And a special thanks to you, our audience, for taking the time to attend and participate today. Please take a moment to fill out our brief survey, which should take only 2 or 3 minutes. It will help us improve your next webinar experience. And please check acm.org and learning.acm.org in the coming weeks for announcements on upcoming webinars. This is Dave Johnson saying goodbye and hope you can join us next time. And if you have any ideas for future topics or speakers, please email them to learning@acm.org. Thank you.